we got the document here. So the lab, this covers chapter 14 of simple harmonic motion. So the focus question in the lab is, how can one measure the elastic constant of an oscillating mass spring system, right? So a lot of the theory, I guess, is in the notes for this section, so you can take a look at that, because we're doing these labs on Monday, so we haven't even gone through the section yet, right? We're going to go over it on Tuesday and Thursday. But what we have for this lab, the materials, it says we have a supporting rod, a spring, a mass, and a ruler. So that's right here. You got your supporting rod. This is the spring. You have certain masses. You have this little block of masses here. And the ruler, because we're going to be measuring the displacement of the spring. Okay. So there's a figure of the experiment here. So it says, recall or teach yourself the relationship between oscillation period, mass, and spring in a simple harmonic oscillator. And it says, by adjusting the amount of mass that is suspended from a spring and measuring the oscillating period, you will determine the value of the spring constant. All right, so it says, arrange the experimental apparatus as shown. So this right there. Make sure you're tightening like this base here to the table, because you're gonna have a mass, so it's gonna tip over if you don't tighten it. And all right, so let's read through this. It says, do not let the total mass exceed 300 grams. You have a combination of masses here, so you can play around with it. Obviously, you can put, this is 150 grams altogether. So if you need, you can put two masses on at the same time, if you like that, and that gives you 150 grams. If you want to just test 100 grams, again, you can restart it, just let it drop. So you see how it's going up and down, this oscillation. That's what we're looking at in this lab. And that's what's covered in chapter 14. All right. So the question that you're going to discuss in the lab group is, how can measurements of mass and oscillation period help you find the spring constant? So we're looking for that K, that spring constant in Hooke's law. How will you measure the oscillation period, which is the capital T? How do you reduce uncertainty in this measurement? And then, so you're going to come to an agreement with your group members to the sequence of measurements you plan to make, how many increments of mass to use. Plan on at least 4 increments. Usually, the more samples, the more trials you have, the better, right? So you can just go up, because if you have more samples, then you can kind of build that linear relationship. So if you want to graph this on Excel eventually, the more data you have, the better. So that the behavior of the, I guess let's call it a function, is clearer. So yeah, how will you determine the spring constant, the percent uncertainty in the spring constant? So you're gonna have a table with different masses. So you'll always start with a different mass, and you're gonna be measuring the total displacement, meaning that's a heavy one. It's measuring how far does it eventually drop. So this oscillation means bobbing up and down, but assuming that it came to rest, like it stopped bobbing, how much did it actually displace? So you see this one is pretty light. If you go up to 200 grams, this displacement is obvious. So note that using your ruler, the displacement is from the starting point. So this is how the spring looked, and then from this point, how much it moved, that's the total displacement, right? It's not the displacement from the top of the spring, it's the displacement of how much it moved. Same thing, obviously, is if you just measure the length of the spring, and you measure when it's not stretched out, and how much the string is when it is stretched out, that's the difference between that is displacement as well. So if you just take it like that and you drop it without letting it bob, then you got your displacement measured out right away. But if you want to look at the period, so probably have to use like a stopwatch or something, right? So you start from here, and as soon as you put the mass on, 1, 2, 3, 4, 5. So you're gonna have to figure out how to measure that period. So you'll probably get your iPhone stopwatches out, or Android. 100 stopwatches. And then the spring constant at K, right? We had, so Hooke's law is this spring force is equal to the spring constant times displacement, right? So the spring constant, that's what we're looking for here. So this is your spring force. And this is your displacement. Okay, so we're looking for this guy. That's the spring constant there. Okay, so percent error formula. So experimental value minus theoretical value over theoretical value.